Perform acid-bases calculations. So for the first problem, they're asking us to find the hydrogen ion concentration, which is this symbol right here. And they're giving us the hydroxide ion concentration. So there's really two formulas that are given to us for us to use. If you notice, they're pretty much exactly the same. Okay, both of them have 1 times 10 to the negative 14, and the only difference is that here you're going to enter your given hydroxide ion concentration, and over here you're going to enter your given hydrogen ion concentration. Okay, so in this situation, we're going to use this one, because that's going to get us to finding the hydrogen ion concentration. All right, so it'll look like this, where we've substituted that symbol for the given number, which is right here. So now the next part, this is how you're going to show your work, and the next part is for us to calculate it using the actual calculator. Alright, so I'm going to show you the keystrokes. It's going to be 1 times 10 to the negative 14 to start it off. So 1 times 10. To get to the power exponent, you're going to use the caret. It looks like that. Negative 14. Just like this. And if you notice that the cursor is clicking wherever the exponent is, we want to bring it down. So we're going to press arrow. And you're going to notice that the cursor now looks longer because it's towards the bottom, not so much on the top. Divided by. And for this step, we're going to have to put parentheses before we put the 2.50 times 10 to negative 2. So, where is it? Parentheses, there it is. Open. Parentheses 2.50. 2.50 times 10. So, times 10. And then to the power of negative 2, we use a caret again. There it is, negative 2. Okay, and there it is entered. We press enter, and it gives us the answer 4e negative 13. That's how the calculator expresses it, but that's not how I want you to write it, so you're going to write it correctly. You're going to write that down as 4 times 10 to the negative 13. The e pretty much means times 10. And then that's the exponent, so it goes up here, negative 13. And as far as the m, that's a unit, and this is how we got the m. If you remember from the formula, it was m squared, and then on the given it was m. So m squared means that it's m times m. The m on the bottom, here it is. You go ahead and cancel a set of m's, and then you're left with that 1 molarity. So this is going to be our final answer. So on your paper, this is exactly what I want you to write as number 1. This is your work, and this is your answer. To find is it an acid, base, neutral, I'll go ahead and show you later on in the video, because I want you to use pH or solving for pH. Yes, there is a chart that uses hydrogen ion concentration hydroxide, but I think it's kind of nicer to have more practice finding the pH. So I'll show you, like I said, later on in the video. For the next set of problems for 4, 5, and 6, what you're being asked to do is to find the pH given the hydrogen ion concentration. The formula is given there. It's a negative log of the hydrogen ion concentration. So what we did is we're going to go ahead and we're substituting that symbol for the number that's given to us, and it'll look like this. So that's going to essentially be what you're going to show for work. pH is equal to the negative log 4.60 times 10 to the negative 5, and we're going to include the unit, although obviously we can't put that onto the calculator. Okay, now entering it on the calculator, you're going to press negative first because it says negative log. So negative, it shows up right here, and then to press the log, if you notice, it's above the 10 to the X button. So we have to press the control key first. So control, then this one, and you're going to see that it says negative log. The other thing is that the cursor is where the base is, and that's not where we want it. We actually want it up here. So to get it up here, go ahead and press your right arrow. And there it is. So now we can actually write down or type in what we have. So the 4.60 or 0.60 times 10 caret negative 5. And then we press enter. Okay, that's going to be our number. It's 4.33724. But what we're going to do is we're going to go ahead and we're going to round it to the nearest hundred. So we're going to put it at 4.34. Okay, so that's exactly what you're going to write on your paper for number 4. And pH does not have a unit, so there's nothing that goes behind it. The M, it kind of goes away, so 4.34. And then they're asking you, is it acid, base, or neutral? All right, so let's take a look at the pH scale, which looks like this. And remember that our pH is 4.34, which is approximately right here. So therefore it's going to be acidic. Anything below 7 is an acid. Anything above 7 is a base. Alkaline is the same as base. And anything that's exactly 7 is going to be neutral. And that's how you would write your answer. And don't forget that you would include your work right here. And then circle the fact that it's an acid. For the 5th problem, I want you to notice that they're not giving you the hydrogen ion concentration, they're giving you the hydroxide ion concentration. So in this case, you're going to first have to find the hydrogen ion concentration, which is pretty much what you did up here. And remember, this is a formula that we're using, just like we did on the first one in the first example. So essentially, 1 times 10 to the negative 14 m squared divided by our given 7.54 times 10 to the negative 3 m. Okay, you get some type of answer. And once you have that, which is your hydrogen ion concentration, you plug it into your pH. And then that's how you would find pH for that one. 7 through 9 are probably the easiest ones you're going to find. All you're going to do for those is subtract 14 from it, or subtract that number given to you from 14. So it's going to be, in this case, the formula pH plus pOH is 14. So 14 minus 3, 11. Okay, that's your pOH. You always want to look at the pH to find if it's an acid, a base, or neutral. Like for this one, you would use the given. So I want to find if this is acid, base, or neutral. Okay, pH is 3. So with a pH of 3, if you look on the scale, it's going to be acidic. On the last set of problems, you're going to be calculating the hydrogen ion concentration given the pH, and then you're going to answer whether it's an acid, base, or neutral. In this case, they tell you that the pH is 8.5. I didn't write the formula for this one, but on this section, this is the formula we're going to use. Hydrogen ion concentration is equal to 10 to the power of the negative pH. So we know that in our paper, they tell us that the pH is 8.5. So what you do is you put 10 to the negative 8.5 and you enter it like so on the calculator. Okay, so you enter 10 caret negative 8.5. Enter, and that's going to be your answer. 3.16 times 10 to the negative 9. And you write it down as your answer. So there you go. This is how you write it on your actual paper. Don't forget that if you're looking for the hydrogen ion concentration or the hydroxide, you're always going to have the unit of molarity at the end of it. And then keep in mind that pH does not have a unit, so it's just going to be a number. So that's it. As for the pH, it's going to be in your given. The pH is 8.5. Looking at the pH scale, 8.5 is approximately right here. Therefore, it's alkaline, which means base, so it's a base.